of a graph that make up a whole graph. And you've probably seen it before, but just kind of went, I don't know what to do with that. This is what it looks like. This is an example, yeah. This is what Piecewise looks like. No, we don't usually do one over there. I mean, you could if you wanted to.
Is this like the thing where you color in the sky that like yeah. On the graph and it's like and if it's done or solid and you like color in the part of the graph.
Oh no, that's not like this. Those are inequalities. If we have time at the end, we may hit some inequalities.
Do that.
All right, so for this one, these are two lines. Do you agree? How do I know that those are linear equations? Like, y'all look at that part. Just look at, there's an x, but everything with an x isn't linear, right? Because we did quadratics. Mx plus b, that's exactly right. Good job. It looks mx plus b. It doesn't have to be in that form. This one is, which indicates that it's a linear. It also, it's just got x to the first power. There's no exponent on x, so it tells me it's linear, right? This is what it always looks like. So what this is this says that the line that I'm graphing is going to be 2x plus 3 as long as x is smaller than 1. But when x is bigger than 1, and even when it includes 1, this is going to be the equation that I use. Okay? So what if I asked you, and we'll graph it in just a minute because that's going to be the main thing we do, but we also do some evaluating here. What if I asked you, what is f of 3? When x is 3, what is the y? Y'all have learned function notation before, yes? F of x is the same thing as y. So if I have f of x equals x plus 1, and I said, what is f of 7? Well, it's just 7 plus 1, which is 8, right? Okay, all right. I just want to make sure y'all got that. Y'all have done that. Come on. So looking at this example, if I asked you what is f of 3, what are you going to plug that into? Where are you going to plug it in? The x, but I can remember it's a function. I can only have one y that goes. The one in the bottom. Why the one in the bottom? 3 is bigger than 1. That's exactly right. This is my x, right? The x is what's in parentheses. So is x bigger than 1 or smaller than 1? It's bigger, so I'm going to use the second equation. So f of 3 is going to be 1/2 times 3 minus 5. I was going to say, I don't know. That's exactly right. That's exactly right. We'll do several examples. So this is 3 over 2 minus 5. And then you can do this on your calculator, math, enter. This would actually be 10 over 2. So you should get negative 7 over 2. So f of 3 is negative 7 over 2. Does that make sense? Well, I did it in my head, but if you did it on your calculator, this is like 10 over 2. So 3 minus 10 is negative 7. You find f of 0. Same thing, same f. What is f of 0? Say again? That's right. I first have to determine which equation I'm using, right? I have to look at 0. Is 0 smaller than 1 or bigger than or equal to 1? Smaller. So that tells me I use the 2x plus 3 equation. So 2 times 0 plus 3, which is, yep. For this particular one, you'll have different ones that you'll have to do. How about, I'm going to try to trick you with this one, okay? Don't answer this one when you get it. F of 1. Think about it and then plug it into the one you think it is. I see a raindrop. Oh. Which one did y'all choose? The top equation or the bottom equation? Why? Y'all are so smart. I tried to trick you and it didn't. This is or equal to, so that means when it is 1, I use this equation. So it's 1/2 times 1 minus 5. Yeah. We're going to graph it. That'd be 10 over 2, so negative 9 over 2. No. Yep. Well, yes, finding the point, yeah. It didn't work? You didn't put it in parentheses. You gotta put All right, so can we all evaluate a piecewise? In other words, if I define a piecewise function like this, you can find any value to plug in, f of whatever you can find. Everybody okay there? Sure? All right, let's get to the good stuff then, which is graphing. I'm going to use the same equation. What did I have? 2x plus 3 and 1/2 x minus 5. What's in the graphic? Okay. What? Boxes? Oh, graph paper. Do I have any graph paper? Maybe. You want me to look? All right, so let's change our f of x. Let's say I told you that f of x was we'll make it easy to start with. Actually, I'm going to make this. All right, we're still lines here, yes? This is still linear. All right. Now before, I'm going to show you 2 different methods of graphing this, okay? You can do whichever method you prefer. One of them is messy but makes more sense. The other one is a little bit easier, and once you get it, you'll probably want to do method 2. But I'm going to show you the first one. I call it eraser method. And it's really helpful in understanding where piecewise graphs are coming from, okay? So the first thing I'm going to do my graph here. Do like a 10 by 10. They'll give it to you just like I have it here. Just like that. Yep, yep. All right, so let's think about, first of all, let's think about what this looks like when I graph it. If I just graph this first equation and I just graph that whole line, how do you graph the line negative x plus 2? Negative 1 is the what? Slope, right? this has a slope of -1. What's the 2 represent? The y-intercept. So that means I start at 2. If the slope is -1, I'm going down 1 over 1 because the slope's -1. Okay, so whatever your slope is, rise is your up or down, run is your left to right. You always go up or down. If it's negative, you go down. If it's positive, you go up, and you always move to the right. So -1 is like -1 over 1, so I would move down 1, right 1. Down 1, right. Yes. Yes. Start. Yeah. The y-intercept is 2. The slope on this first equation. Yeah. Right. No, so I start, when you graph a line, maybe I need to go back. If you have a line in slope-intercept form, you start at your y-intercept, and then you apply the slope to get your second point. This would be up 1 over, bless you, 2. Rise over run. If slope is 1/2, then it's up 1 over 2. Then I'd be down 1. So if it's y equals -1/2 x plus 1, I'd start at 1 because that's my y-intercept, and I'd go down 1 over 2. Yes. Who did y'all have for algebra 1? Yes. Negative only impacts your up or down. All right, is everybody with me now? Yes. Well, I'm showing you 2 different ways to graph this, okay? So stay with me just a second because there's two methods. I'm showing you method 1, which is kind of sloppy, but I'm glad I did because I didn't know y'all couldn't graph a line. So I'm glad I'm not being insulted. I'm not trying. I'm not doing. Y'all don't be. I'm not trying to embarrass you. I just didn't realize that. So I'm glad I showed you this way because otherwise I would. Okay, so is it all coming back to you now? Start at the y-intercept, apply the slope. Slope is rise over run. I either go up or down, always to the right. Okay. Up and to the right. It's always to the right. I am going to graph both lines, but I have to do something first. Does everybody see where this line came from? Yes. Okay. Now I have to look at the stipulation that's attached to it, right? It's telling me that this is the line, but only when x is greater than or equal to 2. Well, where is x2? Right here, right? That's where x is 2. That's where my line's going to cut off. I can only be this equation when x is bigger than 2, which is this way, yes? So that means none of this line is part of my graph. Only this part of my line is my graph. It's a ray. It's like a ray. That's exactly what it is. So all of this is gone, and now all I have left is the piece that is when x is bigger than 2. So I erase the part that doesn't fit. That's why I call it eraser method. Stop. What? Who is it? Don't scare me. Somebody grab that. Okay, so I erase that because this is when x is smaller than 2. X has got to be bigger than 2. So here is 2. X gets bigger this way, so this is the piece of graph that stays. Greater than 2. X is greater than 2. This is where x is 3, x is 4, x is 5, x is 6. It's telling you x, not y. It would be the upper part, yes. Okay? You see it? Okay, watch the second one. It might make more sense. All right, let me add one more little thing here. Because there's a line and it includes, then the starting point, I'm going to do a filled in dot right here. Okay. Now, let's look at the second one, because if you didn't understand the first, that's okay. Stay with me, because I hope you'll understand this other one. All right. No, this is the same method. All right, let's do that blue. Yeah. Yes. So for this one, I'm going to start at -5. 1, 2, 3, 4, 5. All right. And then I apply the slope. The slope is 1, so that means up 1, over 1. Yes? Yes. Yes. If it's a whole number, yes.
That sounds like a
I'll try to find somebody to switch you with. So. All right, yeah. It's 1. Just over 1. Yep. Then it'd be up 5 over 1. Plug in. I'm going to show you. It's easier. All right, we're not done with this one yet, because look, I have to find where to cut it off, right? I'm cutting off the same place, but whenever x is 2, I'm in a different place on the red line, right? This is where I'm cutting off. So am I going to keep the top part or the bottom part of this line if x has got to be smaller than 2? I'm going to keep the bottom part. Does everybody see that, and do you see why? That's the second method I'm going to show you. I just wanted you to see why it was like this, because it's actually the whole lines, and we don't include the parts that don't fit the requirement. So now what I'm going to do, we're cutting it off right here when x is 2, and instead of a filled-in dot there, I'm going to do an open dot because it does not include 2. And then it's going to go forever that way. So that's what that graph would look like. Okay, that's method 1 for graph.
Sometimes there's 3 equations and you have to graph all 3. Sometimes one of the equations is a piece of quadratic that we've already graphed that you'll have to do. I'm sticking you with linear just today until we can piecewise. I need to preview them before I show them that.
oh. I should show you
All right. Let me show you this. Let me show you, if you don't understand this method, it's okay. Let me show you method 2, which is a lot less work. It's kind of a shortcut on it. It's a lot easier. In my opinion, it makes more sense. But I like for you to understand that it's still a line. We're just taking off what doesn't fit, okay? Because it'll help you understand whenever we get to the parabolas and whatnot. All right, so let's take this same function. Somebody, what was it? Negative x plus 2. X minus 5. And we cut it off, what? Greater than or equal to 2. I'm going to do this the same graph, but this time I'm going to do, this is what I call plug-in method, okay? All right, so here's what I'm going to do to plug in. The first thing I'm going to do is plug in the restriction. In other words, where it's cut off, okay? So this one's cut off at 2, so that's what I'm going to plug into this equation. If you plug 2 in this first equation, I get negative 2 plus 2, which is so this starting point, or this point where it's cut, right? That part where I went, oh, wait, this is the boundary. That point is I plugged in 2 and I got out 0. That point is 2, 0. Because that's the end point, should it be open or should it be closed? Closed. Why is it closed? Greater than or equal to, right? So I'm going to put that point here. Now, how many points does it take to graph a line? 2, right? I just need one more point. So here's what I'm going to do. I'm going to, good. Yeah. You can do this next part one of two ways. You can take the slope in the direction it goes, or you can pick an x, this is generally what I do, that satisfies your inequality. It's kind of like an easy point, yeah. So I need an x bigger than 2, right? And I'm going to put, this is where you start. Okay, Malaya says 3. I would agree with 3. Why could I not use 1 here? 1 is less than 2. I could use that on the second equation, but not on the first equation, okay? So if I plug in 3, I get negative 3 plus 2, which is close, negative 1, right? That's okay. That's all right. Negative 1, right?
Because you're under pressure, because you're right here by me. All right,
So this point is 3, negative 1. Are y'all okay with that? No? Who said no? Okay, so plug in this first, and then we plug in an x that is bigger than 2. That's all we did. Okay, so this point that is bigger than 2 is 3, negative 1. And I'm just going to connect. And look at this. Look at this compared to this. Look at the purple line and look at my blue line, right? It's the same thing, little less work to do, right? This is where you start. You always start at step 1. That's okay. That's all right. All right. Let's do the same thing. Huh? What's wrong? No, they don't. It never, we were talking about that in first block. It never picks y'all up. It only picks me up. And so sometimes it sounds like I'm arguing with myself. Or like whenever y'all get loud and I start matching my voice to the noise in the room, it just sounds in the video, it just sounds like I'm standing there yelling like an idiot. You can't hear. If there's a line under the inequality, it's a closed dot. If there's no line, it's open. Yep. All right. Second, I think that's old cleaner that they didn't clean off. All right, second line, same song and dance for the second one. All right, I'm going to plug in the restriction, pick an x that meets the restriction, graph that, and then go. So I'm going to start with 2, and that's going in. So if I put in 2, 2 minus 5 is what? negative 3. That's my starting point, right? Is it going to be open or closed? Open. There's no line under that inequality, right? So 2, 1, 2, 3. If you're good with slope and you want to apply the slope from here, and you know which way to go, knock yourself out. That's a-okay. I would plug one in that meets this requirement. What's less than 2? If x equals 1, what is y? 1 minus 5 is negative 4. So this other point is 1, negative 4, right? I'm fixing to really make y'all mad. What's the domain?
Wait, it's negative and then kind of,
Because it's left to right, right? As I move left to right, oh, I have a roadblock here, but this graph picks it up here, so it's okay. How about the range? I'm fixing to see. How do I say that in interval notation? Smallest to biggest. Do I need a bracket or a parenthesis? Why? And it's a closed-in dot. If that was an open dot, it would be a, yeah. This one's open because there's no line under the inequality there. So at the point 2, negative 3, I'd need an open dot. What is the what?